Hi, this is the beginning of the lecture series for reaction kinetics. So I hope you have your notes with you because this is a very new topic to most students. Very different from what you have seen at the O levels. So the A level, as you can surmise from a quick glance through the assessment objectives, is a lot more than what you have learned at the O level. So a lot of this content is new, so please focus and do your best to follow the notes. This is the lecture outline, so we'll cover this in about 4 lectures. Some of these will require a lot of time to go through. So because a lot of it, you need to get through the process in order to learn what is it about. So without further ado, let's go on to the beginning. So what is reaction kinetics? So previously, you have already learned things such as atomic structure, chemical bonding, energetics. So energetics, you can think of it as we are learning about reactions. Atomic structure and chemical bonding tells you about what the products and the reactants or production of a reaction could be. And that helps you in your understanding of energetics, which tells you whether or not a reaction occurs at all. But it's not enough to just know whether a reaction occurs. It also, very important is also how fast it is. Because there are a lot of implications for how fast a reaction occurs, especially with regards to modern industry and applications. So reaction kinetics deals with that. So how fast is reaction? Energetics tells us whether reaction can occur, whether it's spontaneous, under what conditions we can make it happen, things like that. But kinetics tells us how to affect the rate. How do we make it faster? How do we make it slower? What can we do to manipulate the rate in order to achieve a certain outcome? So the first part of it, the first assessment objective is to explain and use the terms. So you can see all these terms. Unfortunately, for many of them, when we say explain and use the terms, essentially we actually mean define. So for many of these, you need to know their definitions. So the next part, we will go through some of these definitions. So first thing is, what is reaction rate? So the rate of reaction is defined as the change in concentration of a reactant consumed or product formed per unit time. So for this reason, we do not put a sign. And the units will be concentration over time. Over here, we have an example, A plus B to give you C. A and B are reactants, where C is the product. So if we talk about rate, actually, the sign here will be negative, but this is positive. But you may say, hey, negative, but you note that the change in A is decreasing. So actually, this is actually also negative. So 2 negatives add up, 1 positive. So that's why the rate is always positive. Now, one thing to note is that we do not always get to know what the time is. Sometimes it can be up or no, not know what the time is. We may not know what the change is. In practical, when you start on kinetics experiments, sometimes we don't get measured concentration. Sometimes it's a certain particular change. So at times we will just use an arbitrary 1 instead to indicate. So for example, the 1 means something happens. Give an example using practical as an example. For example, the words on the paper are obscured when the dark blue color appears. You're not going to measure the concentration, but we know that when the words are not obscured, it's 0. When the words are obscured, it's 1. So this can be quite an arbitrary change. But this arbitrary change, as I said, is more applicable to practical. But you may actually see it in theory paper as well. So you just have to be flexible. So whenever we have we know what's the change in concentration, or we know what's the arbitrary change, we'll use a stopwatch or some other time measuring device. We know the time, so the rate is inversely proportionate to the time taken. Okay, this is of course, it may seem obvious, but please remember this: the rate is always inversely proportionate to the time taken for the reaction to complete. So of course, the faster the rate, the shorter the time, and the vice versa is true. The shorter the time, the faster the rate, or the longer the time, the slower the rate. Unfortunately, in kinetics, the rate may not always be constant. So we will go through that in greater detail. But now just take a look at figure 1a and 1b. So we have two graphs. Let's just focus on 1a. Graph of reactant against time. Take a note of the axis. This is the axis. Maybe I should highlight this instead. Versus time in seconds. So you notice that the reactant, of course, as a reactant, its concentration will only decrease. It is being used up in the reaction. Right? Then it reacts. You'll note that if we want to find the rate at any one time, we'll have to, in this case, we have to select a specific time. Okay, we cannot just say, oh, the rate is so and so. It doesn't work that way. You have to say the rate at, maybe say 1 second or 2 seconds, or you have to specify a time. And then at that time, you draw a tangent to the curve, you find the gradient of the tangent, and that gradient will give you the rate. And as you can see, the rate will not always be the same. Oops. The rate will not always be the same. At the beginning, the rate is very high, very steep gradient. In this example, at least. Steep gradient, very fast rate. Over here, gradient is 0. Rate is 0. So you can see the rate may not always be constant throughout a reaction. And I hope you will remember this, because this is very important when we study kinetics. Now let's take a look at product. Same thing. At the beginning, if the reactant is reacting very fast to produce the product, of course the formation of product will be fast as well. So that's why over here, again, you have a very steep rate. Then, and you will say, okay, halfway through the reaction, the rate will be slower. Then, at the end of the reaction, it is 0. So reaction has ended. Okay, so I want you to understand that this is how we find rate using a graph. And when we do this, use this method, we actually have to specify a time. Okay, we have to specify a time. We say the rate is so and so at time whatever. Later on, we'll go through this in greater detail. But generally, when we do this comparison, you'll note that most of the time we do not worry about this. We don't select rate in the middle of the graph. No. Most of the time, what we do is we look at initial rate. So you may wonder, okay, what is initial rate? Initial rate is exactly what it means. It means at the beginning of the reaction. So we are very often when we compare different situations where we use different concentrations, etc., we usually compare using initial rates. We do not compare rate at 1 second, 2 seconds, no. We always compare initial rate. That's why it's very important to note at t equals to 0.